All right, you guys have been rock stars so far. We're just being able to work through the atomic theory. Keeping in mind, just let me know if something's not making sense or whatever it might be. Uh, but with that being said, we're going to take a look at the next postulate of the atomic theory. And that one is atoms cannot be created or destroyed in a chemical reaction. So we're going to get a chance to look at that. We're also going to look at some subatomic particles called quarks and leptons. And so keep in mind, a lot of the stuff I am introducing you to, and there's going to be a few of those items that I'm not going to go hugely in depth on because, number one, we're running out of time. Number two, you're going to be building on this in your following years, but at the same time, right now it's okay for you to have just more of a basic understanding of things. So if something's not making sense, talk to me. But we're getting close to being done our atomic theory unit already. So let's take a look here. We have it where, I'm a little ahead of myself here. So you were working on this chart last time. Now for here, it says that atoms can either be created or destroyed during chemical reactions. Now that's correct, that's very true, but at the same time, it does not mean that atoms are the smallest particles of matter. What happens is there's actually something called elementary particles. And those are called quarks and leptons, like I mentioned earlier. And keep in mind, I'm just giving a really basic overview. I'm going to have this video posted first in the lesson. You should have already watched this. If not, I would suggest you pause this video, you go back and watch this one, simply because this will help you be able to understand what I'm talking about next. So watch this one here. It talks about the different types of quarks. There's actually 6 of them. The main ones that you need to pay attention to are the up and down ones. And so something to keep in mind, and they go through the math of it all in the video, but an up quark has a charge of plus 2/3, whereas a down quark has a charge of minus 1/3. And so when you do the math, let's say, and again, they're going to show you that math in that video, but if you do the math, that's how you find out what the charge is, because 2/3 plus 2/3 minus 1/3 actually equals 1 plus 1. Whereas for one up charge, so one up quark and 2 down quarks, that ends up canceling each other out. And because 2/3 minus 1/3 minus 1/3, that just ends up equaling 0. So that shows you how you get the charge for a neutron and the charge for a proton. And keeping in mind, this is a simplified explanation of protons, neutrons, quarks, all of that. But this at least gives you a general basic understanding of what quarks are, the different types there are. The main ones you need to pay attention to are up and down ones, what their charge is, and that they're also, they have a strong bond within the nucleus as well. So they have it where they are they're held together by a strong nuclear force within the nucleus, whereas the leptons, they're going to have more like they're going to, most of them, not all, actually shall I say half of them, are going to have a negative charge, and an electron is one of them. All right, so an electron is going to be one of those ones that has a negative charge. And I just have a couple other little things here. They have it where they're saying how leptons are, they're not, you know, joined like with the quarks, they're joined in the nucleus through the nuclear force, whereas leptons, that's not how they're joined to that atom. What's happening, or within the atom shall I say, they have it where they are joined to the nucleus through electromagnetic or weak forces. So that's what keeps them orbiting around there. They have it where they're held at that distance from the nucleus, a set distance, through electromagnetism. So we'll hopefully get a chance to dig into electromagnetism a little bit more before the end of the school year. We'll see what we have time for. But something to keep in mind is that quarks, they exist only in bound states. So they are bound together, up and down charges and stuff. Whereas the leptons, they have it where they can be individually observed, such as the electron. And so keeping in mind again that electrons, they have a negative electrical charge. And then I just had this little quick thing here to show you. And so it's just basically getting to the point of how quarks and leptons, they're the basic building blocks of quarks, basic building blocks of protons and neutrons. They have the different names for the different types of quarks. The main one you want to pay attention to up and down, leptons. They have it where they, an electron is one of them, have negative charge, and the electrons are the important building blocks for atoms. All right, so taking a look at your notes. Going back here. Now, they just have a brief description of what scientific models are and why they use them in science, especially when they're trying to represent something that maybe you can't easily see with your own eye, such as atoms. That's why we have atomic models. And also, yeah, subatomic means smaller than the atom, which will be our quarks and leptons. Okay, let's fill this in. So quarks form the basic building blocks for protons and neutrons. A proton has 2 up quarks and 1 down quark. Okay. Then a neutron has 1 up quark and 2 down quarks. So then it ends up, when you do the math, they cancel each other out, makes it a charge of 0. Now, the type of lepton that we're looking at right now are electrons. So electrons are a type of lepton that have a negative charge. They're held at a distance from the nucleus through oh my goodness, magnetism. There we go. All right, so that's the basics there. And then looking at elements and compounds. So the next little bit here, there's going to be a little bit more a few questions for you to be able to dig into yourself. So just recapping here, elements, you have atoms that are all of the same kind that are within that element, whereas a compound, you have 2 or more different kinds of atoms in fixed ratios like this. So we have it here where we're going to try to figure out what this is. So we're looking at representations of atoms and elements. And so I want you to see what you can figure out with this. We have this picture here, and I want you to figure out if it is an element or is it, or like, give me one moment. We're gonna see if it's an element and if what you can discern based on what you're seeing in this picture here. So tell me what you see in the picture first of all. Write that down. What do you see? You see a whole bunch of different kinds of atoms. So keeping in mind, if I'm saying different kinds of atoms, you should be seeing atoms of different sizes. And in this case, just because it's a scientific model, it's a diagram, it's not meant to be completely accurate here. But are you seeing different colors as well? Because if you're seeing everything that's the same size and it's the same type of atom, then we would be looking more at an element. And also keeping in mind that when we're looking at, I think it was over here, I believe. Oh, here we go. When we're looking at diatomic and triatomic molecule, oops, it's too far. So we have it where you see 2 of the same atom that is bound together as a diatomic molecule. And so what you're going to do is have it where, looking at this one here, what do you see? Describe it. Do you see different kinds of atoms or just one type of atom? Yeah, what do you see first of all with that? Tell me that. And then are the clusters that they have here, are they tightly packed or are they far apart? Then also, what does it mean if you're noticing, like, quite frankly, I see this and I'm not seeing them being tightly packed. They're actually spread out. So what does that mean? Because when we were looking at the different types of matter as far as solids, liquids, and gas, we saw that solids were tightly packed, they were dense, and they were in fixed ordered ratios. Whereas when it came to liquids, we saw that they were still closely packed, but not the same as solids, and not easily compressed, but there were still some fixed ratios there. Whereas with gas, we saw that they're much more further apart from each other. And so what do you think with this? What's your hypothesis? What is that? Is it a gas, a solid, or a liquid? And then what I want you to do is also answer, do you think it is a mixture of substances or pure substance? Remember, pure substance, we're having it where we're looking at, is that just all one type of element, or is it a mixture? A mixture means you have different elements combined there, whereas pure substance is just one type of element. What do you think? Explain your answer. And then, are the atoms all of the same kind? What do you think? So what I want you to do is, again, look at this. Give me your best guess. What do you think there? What class of substances is made up of only one kind of atom? So take a look back through your previous notes there. And are we looking at compounds? Are we looking at elements? And then finally, we have here, is the substance an element, and then why? So you can have it where you answer yes or no, and then give me your reason why. Give me maybe one or two reasons that would support what you're saying. Okay, so I want you to answer those questions to the best of your ability. This gives you a bit more information here as far as the diatomic and the triatomic. All right, and so remember, a diatomic refers to a molecule that's made of two of the same atoms bonded together. And then triatomic is three of the same atoms bonded together. You do not need to draw a picture here because I'm expecting this to be done online. You do not need to draw a picture. If you really want to, you can get creative and try to do that using shapes and stuff like that in Google Docs, but I am not expecting you to draw anything there. And last of all, what I'd like you to do is have it where you're going to take a look at this and you're going to fill in the diagram. You're going to decide whether each represents an atom or a molecule. So remember, atoms form everything. A molecule is going to have two or more atoms. It could be having it where you have two of the same kind of atoms, or you could even have two or more of different kinds. Like if you look back at your PowerPoint here, take a look at this. We have it where we have just a single atom on its own. There's no bonds with other atoms or anything like that. So it's just an atom. As soon as you add in that second one though, you end up having it where now it is a molecule. All right, so it's still atoms, totally still is an atom, but there's two of them together which form a molecule. And then we have a molecule of a compound here, but it's still technically a molecule, but it has all these individual atoms in there. All right, so compounds are going to have all these different atoms in there, but they are still molecules. So look at that when you are filling this in as far as, is it an atom or is it a molecule? Just have it where you give me your best guess. And then what I want you to do is, oopsies, I'm going too far. I want you to see if you can count this up. How many atoms make up this molecule? And then how many different types of atoms make up this molecule? So number of atoms is like the total amount altogether, just like on here. The total amount altogether for this one was 9 atoms. But as far as if you're looking at different types of atoms, you're looking at really only 1, 2, 3. You're really only looking at 3 different types of atoms, but 9 atoms altogether. So you're going to have it where you can do the same with this. How many altogether, and then how many different types of atoms make up this molecule, and then what holds the atoms together in this molecule. This is where I'm really just looking for a simple answer of things like chemical bonds. All right, there's different types of chemical bonds, but I'm kind of giving you a bit of an out here as far as it's just chemical bonds. That's like the broad term for what would be holding together the atoms. All right, then having it where we're just going to take the last little bit here at the compounds. We have it where we're looking at a water molecule. So all water molecules are exactly the same. We say that the atoms are bonded in, just looking at my notes here so I can write this down properly. The atoms are bonded in a Particular whole number ratio. The atoms in the molecule are held together by a chemical bond. Okay, so what we've been basically trying to get at here is that when we see molecules in a compound, or sorry, atoms in a compound, we see that they're in fixed ratios. They're not sporadic. It's not random. It's always going to be very like deliberate as far as fixed ratios. It's not messy. It's organized. It's ordered. So think about fixed ratios for compounds, and then that they are joined by chemical bonds. And we also know, based on the fourth postulate of the atomic theory, that these bonds are, well, guess what I did? I paused my recording and completely forgot about what I was saying earlier. So, oh well. Pretty much what we've had a chance to do is, like, yes, we mentioned earlier as far as the fourth postulate, which was the atoms cannot be created or destroyed in a chemical reaction. And what we did is then we had it where we were looking at the different components within atoms as far as the looking at a subatomic level. And so we're looking at quarks and leptons, and then we wanted to just have it where we were exploring elements and compounds a bit more, getting a chance to really figure out how to interpret what an element is or a compound, to also be able to interpret how to determine if it's a molecule or an atom, as well as figuring out the total number of atoms, as well as the different kinds of atoms within a molecule. So I wanted to just give you guys some extra practice with that. What we'll do is the next class, we're going to take a look at the fifth postulate of the atomic theory, which was atoms chemically combine in fixed ratios to form compounds. We're going to take a look a little bit more at that next time. What I'm going to have you do, and I'll write this in my notes as well, is that I expect you to be filling this in. And then what you will do is, I said earlier in the lesson that there'll be a Google form. I lied, there will not be. I'm just so used to saying that I realized that that's not going to be the case this time. There will be no Google form. What will happen is I want you to fill in your notes, because there's a lot here for you to fill in, and it's too hard for me to put that into a Google form, and I feel like it's too much work for you guys to have it where you fill all this in your notes, and then I have you do it again on a different document. So with that being the case, when it comes to your notes, please fill it in thoroughly. And what we'll do is, after we finish the last bit of the atomic theory, you're going to send me your entire note package, and I want to see it completely filled out. As far as the stuff that we've covered, keep in mind, I know we've skipped some stuff. There's some stuff you haven't had to do. That's okay. I am not expecting you to fill that in, but I am expecting you to fill in what I've asked you to. And what I've asked you to fill in this time is a few different parts. It's going to be this page right here with the different questions. Then you're also going to have this page right here when you're doing atom or molecule, as well as the follow-up questions afterwards. So I should see everything filled in up to, well, I guess this is technically not the correct page numbers, but right up till we get to chemical formula. You're just having it where you are filling everything up to this point. All right, let me know if you have any questions. You do not have a homework check for this lesson. You do not have a homework check. You will when we're done the unit. All right, have an amazing rest of the day. I will talk to you later.